So let me give you a brief overview of cloud computing technologies. Like, you've heard a lot about IaaS this morning, is that right? Is it heard? Okay. So, so cloud computing is really distributed computing of this decade. Its initial idea came from a computing utility from the Multic system in the 1960s. So it's this kind of recycled idea. And it's a computing utility that provides services over network, like computing, storage, and basically it pushes functionalities from devices at the edge, like mobile phones and laptops, to centralized servers. So the kind of pieces you see of a cloud computing system are user interface, a resources and services index, system management and monitoring, and also storage and servers. And there's three basic types you see out there. One's called infrastructure as a service, one's called software as a service, and one's called platform as a service. So there's some fundamental differences between these that kind of lead to confusion when people talk about cloud computing. And a cloud computing infrastructure can include one or all of these, okay? So infrastructure as a service, it's a virtualization environment. So usually the cloud computing service provider offers the capability of hosting virtual machines as a service. And Amazon 2 is one example of this. Has anyone here ever used Amazon EC2? What's your experience been with it?
It's been fairly transparent. We had just a virtual box that we sent to it. I'm a biologist, so I don't.
Was using VirtualBox on it?
Yeah, just push my software to it.
Okay, so you found, I'm going to repeat for the other people. So you found that it's pretty transparent. You use VirtualBox, you just push your VM image out to it. So you build your VM on Windows, and then you push your VM image out using the VirtualBox image out to Amazon EC2, and it just picks it up. That's cool. Okay, that's good. Any other uses of Amazon here? So one of the problems of Amazon is the cost, right? So you have to do a financial benefit calculation for that. So the enabling technologies used to provide infrastructure as a service. On the virtualization layer, there's the VMware, Xen, KVM, OpenVZ. On the network layer, you need to provide a VPN and network security for private VMs. And the scheduling layer, one problem is managing the mapping of infrastructure as a service requests to the physical and virtual infrastructure. So Amazon EC2 provides this scheduling. OpenNebula, Eucalyptus, and Nimbus also provide scheduling services as well. So the benefits of infrastructure as a service is you don't have to provide your own infrastructure. There's no servers or data center required. It can be a very low cost of entry. You can't have it as a pay-as-you-go computing like Amazon EC2. And you need limited systems administration staff. And I'd say it's not zero, because you have to know what you're doing with Linux. So get some help if you don't know what you're doing. So some examples, there's a commercial provider called Blue Lock in Indianapolis. Eucalyptus is another example that started as a research project by Rich Wolski at UCSB. It's a company now. OpenNebula is what I've had a lot of experience with. It was developed in Europe, and it leverages the usual Linux technologies like SSH and NFS, so it's pretty easy to debug when you're trying to get it working. And the scheduler for it is named Hazia. And Nimbus is another project at Argonne that's linked with Globus. It's another IaaS system. Platform as a service is the next layer up. It builds on the virtualization platform, provides a software stack in addition to the virtualization service. So if you needed to run a web server and didn't want to install Apache and Linux, you could use a platform as a service to do that. So some of the benefits, you don't need to focus efforts on getting software infrastructure working, and you can focus on your service and development efforts on your product, not rather than the infrastructure. It's also pay-as-you-go. So some examples are Amazon Web Service. So WikiLeaks was using this. I think Netflix is using it. So when EC2 goes down, Netflix kind of gets messed up. That's what you've seen. Some other examples are Google App Engine and Microsoft Azure. So software as a service is another layer above that. And software as a service provides access to software over the internet with no download or installation of the software needed. Users can lease or rent the software. This was a really big idea about a decade ago. I mean, people were going to rent applications over the web. And it sort of came and it sort of died. And it's kind of coming back now as cloud computing, which I think it makes sense. It's in a different context now. It's making more sense. And so the idea is that software runs remotely and displays back to the user. So think like VNC. Is anyone familiar with VNC? Virtual Network Computer. So if you want to have, has everyone used SSH before? Yeah, everyone's used SSH, right? Okay. So imagine having like something like SSH, you could actually get like a remote screen. That's what VNC is for. So Tiger VNC is what I use. It works really well. So I suggest you take a look at it if you want to go beyond just SSHing. And so NEESHUB is an example of this. In NEESHUB, users can run tools in a window without the need to download and install software, and I'll show you an example later on. So some of the benefits, there's no need for users to download and install software. It's easier to support. You can control the computing environment centrally. And it can be faster as long as the server hardware is decent. So for OpenSeas, we work with a researcher Berkeley named Frank McKenna who wrote the software, wrote OpenZeus. And he's finding that running it in our NEESHUB infrastructure is faster than he can run it on his own computer. So he's like, I want to use yours because it's faster. So we can really centralize the hardware and make it run faster. So let me talk about the relation of cloud computing to HPC now. So use of cloud computing really depends on how the application is used. So when you look at software as a service, we have what's called a batch submit capability we developed for NEESHUB, where users can run OpenSeas on the Open Science Grid or Exceed. And rather than giving them, we're trying to get to the point where users don't have to SSH into the Exceed system directly, the OSG system directly. They go to the NEESHUB and interact through a panel that lets them set parameters and click on submit or simulate, or else give them a workspace so they can do a little bit of editing and then run batch submit. So we're trying to ease the process for earthquake engineering users to use OpenSeas without the need to become like Exceed experts, right? Or learn all about how Open Science Grid works. So in that regard, when we have canned applications where the users are not the developers of it, we just want people to use them, software as a service is a great approach from a cloud computing perspective to provide this access to these applications. On a lower layer, infrastructure as a service, you can build HPC clusters on an infrastructure level. And the problem here is a little bit different. It's to deploy, operate, and use a collection of VMs to constitute or constitute a virtual HPC cluster. And the capabilities of this area then focus on VM image and network management deployment, less so on the user interface. WebEx can be slow. All right. The WebEx moment here, sorry. There we go. So from a user's perspective, what do you need to use this technology? So if I'm going to use software as a service, or let's say you're going to write your application provided as software as a service, users are going to need to discover your application, find out where it's at, launch it, monitor execution, and collect and analyze results. If instead you provide software through an infrastructure as a service, we're either developing an IaaS or providing it, users are going to discover the resources they need, provide a VM image or create a new one, deploy the image on the cloud computing system, set up the network, set up an MPI ring, launch the application, monitor execution, and collect and analyze results. So if you're trying to build a parallel application and have a large community of users gather around it, it's going to be more beneficial to set it up as a software as a service for users. Okay? For developers, you really want more of an infrastructure as a service. They can get underneath the covers and work on the code. Okay? There's kind of a difference there. So here's an example of NEESHUB software as a service. So we have a software called CSMIP that was contributed by John Martin and Associates from San Francisco, a civil engineering firm. And this is an application that has within it a lot of response data of buildings collected in the field over the years. So users can go here, start up. It's actually a Windows XP application. We had to get it running. It was something else we're finding too, is old software needs old operating systems to still run. Users can start this up through the NEESHUB. They can go look at a building and look at some of the data collected from that building over time. So what we're kind of doing is, in a way, we're starting to archive and curate not only the software, but also the operating system needed to run this software. Okay? I tried getting this working in Windows 2007, and it wouldn't work because it used an old version of DirectX, and there wasn't enough resources to recompile it for the new version of Windows. So this is a way of saving this application from being stranded. Some other examples, this is Linux applications. One's a Global Earthquake Explorer, and the other one is, I don't remember the name of this one. It's Visual Laboratory. So these are Linux applications that run as software as a service. So behind these two are basically that workspace that I showed you in the NEESHUB.